Hello children, today we will solve competency and critical thinking based questions. I have taken these questions from Oswaal Books, CBSE Question Bank, Class 10 Mathematics Standard. Every chapter of this book consists of a quick summary, mind map, various types of questions, and they are MCQs, very short answer type questions, short answer type questions, long answer type questions, assertion and reason based questions, and case based questions following the latest CBSE question paper pattern. Along with that are toppers answer sheets and self-assessment question papers and much more. So in short, it is a must-have for your bookshelf as soon as possible. It is available on Amazon. Link is given in the description box below. So let us start solving some of these questions. First question, the LCM of two numbers is 2400. Which of the following cannot be their HCF? HCF is always a factor of LCM of the given two numbers. Let us understand this with the help of this example. Consider two positive integers are 4 and 18. 4 can be written in terms of its prime factors as 2 to power 2 and 18 can be written as 2 to power 1 into 3 to power 2. So LCM of 4 and 18 will be 2 to power 2 into 3 to power 2, that is 36. And HCF of 4 and 18 will be 2 to power 1, that is 2, as explained in the previous video. So here you can see that HCF, that is 2, is a factor of LCM, that is 36. Means 36 is completely divisible by 2. So the same concept we will apply here. So out of these numbers, the number that cannot completely divide 2400 will be the answer. So the answer is C. Second question, find the LCM of smallest two-digit composite number and smallest composite number. So we know that smallest two-digit number is 10 and it has factors as 1, 2, 5 and 10, means more than 2 factors. So it is smallest two-digit composite number. Let us find out smallest composite number, means smallest one-digit composite number. We know that 1 is neither prime nor composite, 2 is smallest prime number, 3 is also prime number, and 4 has 3 factors 1, 2 and 4. So it is the smallest composite number. Now we will find out the LCM of 10 and 4. So 10 can be written as 2 to power 1 into 5 to power 1 in terms of its prime factors, and 4 can be written as 2 to power 2. Now we will find out LCM of 10 and 4. So the prime factors involved in these two numbers is 2 and 5 and their maximum power is 2 and 1 respectively. So LCM will be 2 to power 2 into 5 to power 1, that is 20. Third question, write the smallest number which is divisible by both 306 and 657. Sometimes we wonder whether to calculate LCM or HCF of the given numbers. So the trick is to read the question carefully and guess the number to be calculated is greater than or less than the given numbers. If it is greater than the given numbers, you need to calculate LCM. If it is less than the given numbers, you need to calculate HCF. So let us figure out what we have to do in this case. Write the smallest number which is divisible by both 306 and 657. Suppose the number is x. So x is divisible by 306 and x is divisible by 657. So obviously x should be more than 306 as well as 657. So we need to calculate LCM of these two numbers. So let us factorize them first. So 306 can be written as 2 to power 1 into 3 to power 2 into 17 to power 1, and 657 can be written as 3 to power 2 into 73 to power 1. So the prime factors involved in these two numbers are 2, 3, 17 and 73 and their maximum powers are 1, 2, 1 and 1 respectively. So LCM of these two numbers will be 2 to power 1 into 3 to power 2 into 17 to power 1 into 73 to power 1 and that will come out to be 22,338. Fourth question, the length, breadth and height of a room are 8 meter 50 centimeter, 6 meter 25 centimeter and 4 meter 75 centimeter respectively. Find the length of the longest rod that can measure the dimensions of the room exactly. In this case, length of the longest rod will be less than all three dimensions in order to measure them exactly. So we need to figure out HCF of these given numbers. First step is to convert them in single unit. That is, length is 850 centimeter, breadth is 625 centimeter and height is 475 centimeter. Now we need to factorize them. So 850 can be written as 2 to power 1 into 5 to power 2 into 17 to power 1. 625 can be written as 5 to power 4 and 475 can be written as 5 to power 2 into 19 to power 1. So the common prime factor in all these numbers is 5. And what is its minimum power? That is 2. So HCF of these three numbers will be 5 to power 2. That is 25 centimeters. Means length of the longest rod should be 25 centimeters to measure the dimensions exactly. Fifth question, if HCF of 144 and 180 is expressed in the form 13m minus 16, find the value of m. First, we need to factorize 144 and 180. So 144 can be written as 2 to power 4 into 3 to power 2. And 180 can be written as 2 to power 2 into 3 to power 2 into 5 to power 1. Now the common prime factors in both the numbers are 2 and 3. And what is their minimum power? Minimum power of 2 is 2 and minimum power of 3 is also 2. So HCF of 144 and 180 will be 2 to power 2 into 3 to power 2, that is 36. Now it is given in the question that HCF of these two numbers is expressed in the form 13m minus 16. So we need to equate 13m minus 16 with 36. So we will get value of m as 4. That is the answer. Sixth question, write whether 2 root 45 plus 3 root 20 upon 2 root 5 on simplification gives an irrational or rational number. So first we will factorize 45 and 20. So 45 can be written as 3 to power 2 into 5 to power 1 and 20 can be written as 2 to power 2 into 5 to power 1. So we can simplify this as, in place of 45 we will write 3 to power 2 into 5 and in place of 20 we will write 2 to power 2 into 5. So square root of 3 square we can take 3 out and square root of 2 square we can take 2 out. So it will become 2 into 3 root 5 plus 3 into 2 root 5, that is 6 root 5 plus 6 root 5 upon 2 root 5. So it will be 12 root 5 upon 2 root 5. So root 5 will get cancelled and 2 6 are 12. So answer will be 6, which is a rational number because it can be written as 6 by 1. So on simplification, this expression will give rational number. Seventh question, given that root 5 is irrational, prove that 2 root 5 minus 3 is an irrational number. We will solve this by the method of contradiction. Assume that 2 root 5 minus 3 is rational number. So we can write it as 2 root 5 minus 3 is equal to a by b, where a and b are co-primes. Take 3 to the other side. So 2 root 5 is equal to a by b plus 3, or 2 root 5 is equal to a plus 3b upon b. Take 2 to the other side. So root 5 is equal to a plus 3b upon 2b. Right hand side is rational and left hand side is irrational, as it is given as root 5 is irrational. That is not possible, means irrational cannot be equal to rational. So our assumption that 2 root 5 minus 3 is rational number is wrong. Actually 2 root 5 minus 3 is irrational. Eighth question, 3 sets of science, history and drawing books have to be stacked in such a way that all the books are stored topic wise and the height of each stack is the same. The number of science books is 192, the number of history books is 480 and the number of drawing books is 672. Assuming that the books are of the same thickness, determine the number of stacks of science, history, and drawing books. It is given that there are three sets of books subject wise. They are 192, 480, and 672. And it is also given that the thickness of each book is same and height of each stack is also same. That means number of books in each stack will remain the same in all the stacks. So we need to find out that number. Obviously, that number will be less than all these numbers. So we need to find out HCF of these numbers. So first step is to start factorizing them. So 192 can be written as 2 to power 6 into 3 to power 1, and 480 can be written as 2 to power 5 into 3 to power 1 into 5 to power 1. 672 can be written as 2 to power 5 into 3 to power 1 into 7 to power 1. The common prime factor in all these three numbers is 2 and 3. And what is their minimum power? That is 5 and 1 respectively. So HCF of these three numbers will be 2 to power 5 into 3 to power 1. That is 96. It means there are 96 books in each stack. So number of stacks of science books is equal to total number of science books upon number of books in each stack. That will be equal to 192 upon 96, and that is equal to 2. Similarly, we can find the number of stacks of history books, that is 5, and number of stacks of drawing books, that is 7. It means there are 2 stacks of science books, 5 stacks of history books, and 7 stacks of drawing books. Ninth question, assertion and reason-based question. Direction. In the following question, a statement of assertion A is followed by a statement of reason R. Mark the correct choice as option A if both A and R are true and R is the correct explanation of A. Option B, both A and R are true but R is not the correct explanation of A. Option C, A is true but R is false. Option D, A is false but R is true. Assertion is given as if HCF of 336 and 54 is equal to 6, then LCM of 336 and 54 is equal to 3000. Reason R is given as the sum of exponents of prime factors in the prime factorization of 196 is 4. So first step is to check whether A and R are true or not. First A. HCF of 336 and 54 is equal to 6 and LCM of 336 and 54 is equal to 3000. So we will start factorizing 336 and 54. So 336 can be written as 2 to power 4 into 3 to power 1 into 7 to power 1. And 54 can be written as 2 to power 1 into 3 to power 3. For HCF, we will see what prime factors are common in both the numbers. They are 2 and 3, and minimum power of them is 1 and 1 respectively. So HCF is 6, and that is correct. LCM of these numbers, we will find out what prime factors are involved in these two numbers. So they are 2, 3 and 7. And what are their maximum powers? That is 4, 3 and 1 respectively. So LCM will be 2 to power 4 into 3 to power 3 into 7 to power 1. That is 3024, and it is given as 3000. So A is false. Let us check R. The sum of exponents of prime factors in the prime factorization of 196 is 4. So start factorizing 196. So 196 can be written as 2 to power 2 into 7 to power 2. Now the prime factors involved are 2 and 7, and their exponents are 2 and 2 respectively. So sum of the exponents of prime factors will be 2 plus 2, that is 4. So R is true. A is false but R is true. So we will check out the option. Option D says A is false but R is true. So D is the correct option. Last question, it is a case-based question. Read the following and answer any 4 questions from Q1 to Q5. Educational organization means any organization within this state that is not organized for profit, the primary purpose of which is to educate and develop the capabilities of individuals through instruction by means of operating or contributing to the support of a school, academy, college, or university. A seminar is being conducted by an educational organization where the participants will be educators of different subjects. The number of participants in Hindi, English, and mathematics are 60, 84, and 108 respectively. First question. In each room, the same number of participants are to be seated and all of them being in the same subject, hence maximum number of participants that can be accommodated in each room. Here are the options given. It is given that the number of participants subject-wise are, for Hindi there are 60, for English there are 84, and for mathematics there are 108 participants, and they are to be seated in different rooms subject-wise, and capacity of each room is fixed, means number of participants that can sit in a room are fixed. So we need to figure out that number which is fixed for each of the rooms here. So we have to find out that number by taking the HCF of these numbers, because that number means capacity of each room is going to be less than each of these numbers. So start factorizing these numbers. So 60 can be written as 2 to power 2 into 3 to power 1 into 5 to power 1. 84 can be written as 2 to power 2 into 3 to power 1 into 7 to power 1. 108 can be written as 2 to power 2 into 3 to power 3. So SCF can be figured out. We need to see that what prime factors are common in these three numbers. They are 2 and 3. And minimum power of 2 is 2 and minimum power of 3 is 1. So SCF will be 2 to power 2 into 3 to power 1. That is 12. So there are 12 people that are sitting in each room. So the correct option will be option B. Second question, what is the minimum number of rooms required during the event? We have found out that the HCF of these three numbers is 12. So there are 12 people sitting in each room. So number of rooms required for Hindi will be equal to number of people related to Hindi upon capacity of each room. So that will be equal to 60 upon 12, that is 5. Similarly, number of rooms for English will be 84 upon 12, that is 7. And number of rooms for maths will be 108 upon 12, that is 9. So minimum number of rooms required for the event will be 5 plus 7 plus 9, and that is 21. So the correct option is option D. Third question, the LCM of 60, 84 and 108 is, these are the options given. So LCM of 60, 84 and 108 can be figured out from here. Prime factors that are involved in these three numbers are 2, 3, 5 and 7. And what is their maximum power? Maximum power of 2 is 2, maximum power of 3 is 3, maximum power of 5 is 1, and maximum power of 7 is 1. So LCM is 2 to power 2 into 3 to power 3 into 5 to power 1 into 7 to power 1. And that comes out to be 3780. So the correct option is option A. Fourth question, the product of LCM and HCF of 60, 84 and 108 is. These are the options given. We have already figured out LCM of 60, 84 and 108 is 3780 and HCF of 60, 84 and 108 is 12. So LCM into HCF will be 3780 multiplied by 12, and that comes out to be 45,360. So the correct option is option D. Fifth question, 108 can be expressed as a product of its primes as, these are the options given. So we will factorize 108. So 108 can be written as 2 to power 2 into 3 to power 3. So the correct option is option D. In next video, we will start second chapter, and that is polynomials. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.